Hello everybody, this is Mr. Storm, and this is part 2 of our Pong Unity tutorial. We're using 2D Unity, so this is not a 3D game, this is a two-dimensional game. Let's go ahead and review a couple things that we went over in the last video. First of all, we changed some settings for our main camera to make sure our background was nice and black. We changed the size of our camera so that it fits our game, and I might actually change it just a little bit here. So we get, so it looks a little bit nicer. Okay. 30. Yeah, 30 is probably better. We imported our wall pieces, and we imported the dotted line down the middle. We imported our rackets and the ball. And we organized our folders a little bit better. Now we need to get into actually programming this thing. So what I'm going to do is I want to make sure, first of all, I want to move my rackets. So I'm going to select both of my rackets. I'm just going to make sure one's highlighted, hold shift and click the other. Because you can apply components to both items at the same time. And I'm going to apply a new component and I'm going to make it a new script. So this is going to be a new script. I'm going to call it move racket. And I'm going to make sure it's in the C# language, and I'm going to click Create and Add. Now, for a moment, we will see the script move racket is going to not be, it'll be vibrant here. But now, oh, get out of here, Java update. Now it's gone gray, which means that it's ready to be applied to, it's now attached to this object, and we can make manipulations to it. Now, you might be wondering, how do I actually start writing some of that script? Well, when we created that new script, it actually put it over here in our File Explorer. And specifically, it put it right into the Assets folder. So we're going to want this to go into our Scripts folder, this move racket, and we can see what the code is inside of it over in the inspector if we click on it. I'm actually just going to click and drag it up into my Scripts folder just to keep things more organized. And I'm going to go into the Scripts folder and double click on Move Racket. Now this will open up my standard compiler, my standard programming interface, my integrated development environment. And the IDE that I'm using is Microsoft Visual Studio. It's the one we're using in class as well. So this should be pretty familiar. Now, some tutorials will show you MonoDevelop or some other IDE. That's fine. You can use any one of those you want. For me, I choose to use Visual Studio because I like it the most. All right. Now, a couple things when it comes to programming for me. I'm the kind of guy where I like my brackets to be on the same line, the same area. Now, by default, Visual Studio doesn't keep it that way, so I just kind of instinctively I put my bracket on the next line, and I also get rid of these two methods. Let's talk about these really quick. So this the start method is it's one of the default methods that gets created with Unity. And essentially what this means is anything inside of this method is going to just be run once whenever the game or whenever that script is called. So whenever you call that script, that start method is going to be, whatever's inside there is going to be what fires off at the very beginning. And then the update method, whatever's inside here gets fired off once per frame. Now, this all depends on the frame rate of your game. If you have your frame rate set to 60 frames per second, and if it's running at a steady 60 frames per second, then this, whatever's in update, will fire off 60 times per second, right? That makes sense? So those are the two default states, or the two default methods that get kind of built into any script you build in Unity. For the most part, we're not going to use those because we like to use our own custom methods or methods that are a little bit more, let's say, interesting. And if we do need to use the start method or the update method, we'll just write it in. So I like to start with a clean class whenever I start coding a new script in Unity. All right, so let's think about what we need to do with this thing. This thing needs to be able to actually move our rackets up and down. All right, so it needs to access the rigid body because we're going to be moving those rackets in certain space. It needs to have a speed, a public speed variable that we can change, the value of the how fast it's moving in Unity, and it's public so that we can manipulate it in Unity and we don't have to keep coming back into our code. So there are a lot of things we need to do with this thing. But the first thing is we need to have a method to wrap everything in. Now, we just got rid of start and we got rid of update. Now, what we're going to need is something like update, but we want something a little bit more sophisticated. For example, remember when I said update is actually fixed to the frame rate? Fixed update is different. What fixed update does is let's see, how do I explain this in a way that doesn't get too deep into the weeds? Let's see. So basically what fixed update does, instead of being tied to the frame rate, it's tied to a specific time interval. So it's a fixed timed interval instead of the frame rate. So if you think about it like this, if you're playing your game and it's at 60 frames per second, but there's too much stuff going on, there's too many zombies blowing up, cars are crashing into each other, whatever it is, and your frame rate starts to dip. Let's say it dips down to like 30 frames per second. With an update method, then the code that you're running is going to be called only 30 times per second, as opposed to 60 times per second as you planned. With fixed update, it's not tied to frame rate at all. It will pull it at a specific time frame no matter what else is going on in your game. So that's kind of, sometimes you want to use fixed update, sometimes you want to use a regular update. It just depends on what we're doing. With this, we're going to use the fixed update so that we can make sure our game is incredibly smooth and we don't have to worry about any kind of physics bogging down our game. Usually when you're doing physics kind of stuff, you're going to want to use a fixed update for that. So let's go ahead and write that in. So I'm going to do void fixed update. Now you can see it already pulled up the tooltip for it because it recognizes this. Fixed update is something that Unity recognized. And as soon as it pulls that up, all I have to do is hit tab or enter, and it will just finish building the rest of that for me, which is great. Make sure you spell this stuff properly because it is something that Unity recognizes, and if you misspell it, it's not going to understand what you're trying to type in. All right, so now I have that in. Now let's start building in some of the other stuff. So first of all, what I want to do is I want a variable that's going to pull in the value of the axis that people are using. So axis is up, down, left, right. I want to get the value of that and convert that into some kind of number, and then I can use that number to times that number by speed to get the direction that I'm going and how fast it is. So I'm going to create a floating point variable. Float. I'm going to call it float. I'm going to call it V because this is going to be our vertical axis. Because we're not going to worry about horizontal in this game because our paddles only need to go up and down. And then I'm going to use input dot get axis raw. And I'm going to get the vertical axis. Now, get axis raw is incredibly important to understand. What get axis raw does is it looks for a specific axis that's identified in Unity, which we'll cover in just a minute. There are many different axes, whatever the plural for that is, but there are many different axes in Unity that you can identify. And for this example, we're using the vertical axis. So whatever the name vertical, whatever axis the name vertical is tied to, we're going to pull in that input. We're using raw because we want to make sure that we get a smooth portion of that axis. We don't want it just to be a binary thing. We want to get the raw input of that. So if we're using a joystick, it can go up and down smoothly, that kind of stuff. But yeah, get axis raw is what we're going to use for the most part. Alrighty. So what's next is we want to make sure that we have our float variable, we have our V variable for our vertical input, a number that represents the button push that we're putting in there. Now we want to actually apply that to our paddles. So we need to get the component of those paddles, and specifically we need to get the rigid body 2D component, because the rigid body 2D is what allows us to make physics changes in the game, right? So if we access the rigid body 2D component of our paddles, and specifically the velocity component, because we need to change the speed and the direction that it's traveling, and we're going to set it to a new vector 2. Vector 2 seems confusing, but vector 2 is simply just a variable that holds two different values, two different vectors. And we're going to set the first vector to 0 and the next vector to whatever is in our V. Oh, okay. Now, it's okay if this is confusing right now, because the more you do this, the more it's going to make sense to you as you go through it. So now we're pretty much done, but we need to make sure that we can change how fast our paddles will travel back and forth, or in this case, up and down. We need to be able to change that in Unity. So we have it timesing by how much we're pushing up on the joystick or pushing the button or whatever. We need to actually times that by a public variable called speed. So let's create that. Now, make sure you create it outside of your fixed update method, because if you do it inside fixed update, it's not going to be applied immediately. We want to do it outside. Plus, we need to worry about scope, and this is going to be a global variable, so we want to make sure we do it outside of the fixed update method. So let's do, up here, let's make a public, we will make it a float, because we do not want it to be an integer variable, and we'll call it speed. And that we'll set it to 30. Okay. Now we need to use this variable in some way. So what we're going to do down here is, instead of applying the vector 2 by itself, we're actually going to times the vector 2 by whatever's in the speed variable. Okay. So now that is our entire movement script for right now. If yours looks like mine, then you're good to go ahead and attach this script to Unity and move on. I'll show you how to do that. If you don't understand every single thing that we wrote in here, again, that's okay. The more you do this, the more it's going to sink in. But really quickly, so we have our public variable called speed, and we set that to 30. We're going to be able to change that later on as well. We have our float variable. We have a float V. And that V is simply just the vertical axis. We're accessing that by calling getAxisRaw. So whatever the vertical axis is tied to, which we're going to talk about in just a little bit. Then we're going to get the component, specifically the rigid body 2D component, specifically the velocity value of the rigid body 2D component. And we're going to set the velocity to be a new vector 2. So namely 0, and then V, which is this vertical, times speed. Okay, so now whenever we're ready to go back to Unity, all we have to do is go up here to this green button, and it says attach to Unity. Click that. It's going to run debug mode to check to see if there are any mistakes in your code, which I'll pull this up so we can see how that's doing. Everything looks good. It's now in debug mode. Now, if I go back to Unity now, there won't be much of a change. First, I want to pull it out of debugging, because now it works. It looks good. We know that there aren't any issues with the code. I'm going to click this red button to stop debugging, and then I can go back to Unity. And now what I can do is, when I click on my racket here, I can go over here to this move racket script that we just wrote, and I can see the speed variable. I can change that up and down. But I want to test my script first to make sure it actually works. And there's no better way to test a script than to actually play the game. So I'm going to hit play. And now when I hit W or S, W goes up, S goes down. Now how do I know, and the up and down arrow keys work as well. How did I know those actually were tied to those specific keystrokes? Well, we'll get into that in just a minute. But just know those are traditionally WS, and up and down are traditionally the keystrokes you'd use for moving up and down in a video game. Alrighty. So that was pretty fun, pretty easy. Let's talk about how we knew what those keystrokes were. Now that wasn't just because I know, I play a lot of video games. Okay, let's put that on the table right now. I do play a lot of video games, and I know that usually WASD are movement on a keyboard. Now, I don't expect anyone to know that coming into making this kind of a game or making this doing this programming. So let's talk about how we figured that out, and let's talk about how we can change that so that we can rebind our keys in our game so we can make what buttons we want do what we want them to do. All right. So I'm going to go up to Edit, and I'm going to go to Project Settings and Input, because we're going to look at the inputs that we have programmed for our game. So I'm going to go to Input, and over here in the Inspector, it changed to Input Manager, and I have this little option right here, Axis, which, wait a second, that actually reminds me of something we just did, remember? Get Axis Raw. Oh look, it's input.getAxisRaw. So we're going to get an axis over here. So what axis are we going to be looking for? We're going to be looking for an axis called vertical. Okay, great. So let's go back here. Let's see. So we have 18 axes. We have horizontal, vertical, fire 1, fire 2, fire 3, jump, mouse X, mouse Y, mouse scroll wheel. These are all default ones that are built in Unity for us whenever we start a new project. Let's take a look at the vertical axis real quick. So if we're getting the vertical axis, if we're getting that raw value from the vertical axis and applying it to our V variable over here, what we're getting is these button pushes. We're getting the positive button or negative button pushes for down and up arrow keys, or the alternative positive and alternative negative, the W and S, right? And the positive will create a positive number if we push that button. The negative will create a negative number if we push that button, right? And we have all kinds of things like gravity and dead zones and sensitivity and snap and all these kinds of things that we can play with. But for right now, really what we need to focus on, I really want you to make this connection, is that when I push this button, this W button, that sends a positive value to the vertical axis, and if we're pulling the vertical axis, we're getting a positive number, and we're putting it in this V variable, which then in our get component rigid body 2D velocity thing, what we're doing is we're taking that positive number and we're applying it, we're timesing it by our speed, we're multiplying it by speed. So we have a positive number multiplied by speed, and that goes into our velocity of our rigid body. So that's what makes our paddle go up, right? It's the same thing if we use the negative key. If we hit S or the down key, it produces a negative number times, times speed gets put into our velocity of our rigid body. So this is how we're making that our code. This is what our code is doing. It's taking these values that already exist and we're manipulating them in some way. So can we make this? Can we manipulate this so that we can actually play this game two-player? Well, absolutely. What we need to do is just add a new vertical or add a new axis, because we're going to add a vertical 2 axis. So we have our size, we set that to 19. And when we come down here, we have an extra cancel button down here, which we can change. I'm going to change this cancel. I'm going to call it vertical 2, because this is going to be for our 2-player. And I'm going to set the positive button to be up, and the negative button is going to be down. And I'm going to make sure I have no alternatives. I'm going to set the gravity to be 3. The dead zone's fine. Set the sensitivity to be 3. I'm going to set snap so that it, when we reverse direction, it doesn't have to go all the way back up. It can start from the middle and go back up. And then up here in my original vertical axis, I want to make sure I get rid of these positive and negatives. And I want to actually remap this so that my negative is S and my positive is W. So now what we have is vertical 1, it goes up and down on the S and W keys, and vertical 2 goes up and down on the up and down arrow keys, right? So now we've just basically set up a vertical axis, 2 different vertical axes, one for each player. So I'm going to show you how to make that happen in the code right now. Let's talk about how to make it so that we have separate players in the code. So what we're going to do is I want to set up, let's go back to the code. So now instead of having, as well as having this public float speed, what we can do is we can create a public string. Public string. I'm going to call it axis. I'm going to set it equal to vertical. Okay, so our first player is going to be tied to the vertical, but because it's public, I can actually change that to vertical 2 for the other player. Cool. So I have it set to vertical right away, and instead of calling the get axis raw of vertical right off the bat, I just want to call whatever's an axis, because what we're going to do is we're going to change the value of this axis variable inside of Unity, because it is public, so that way we can change it inside of Unity. So instead of always calling vertical, sometimes it might call vertical 2, and it will if we're applying it to, if we're talking about the second paddle. So those changes have now been applied. It's pretty easy stuff, didn't really have to do much. I'm going to click Attach to Unity. I'm going to stop the debugging, and then I'm going to go back. And now what I want is I want to make sure that this paddle is set for vertical, which it is, the vertical axis. And I want to make sure this paddle is set for vertical 2, because that's going to be our second player. Okay? So now that's vertical 2, that's vertical. Perfect. Now, if everything is right, if we've done everything right, all we have to do is hit play, and now we can go up and down independently. So that's our player 1 on the W and S key. That's our player 2 on the up and down keys. Okay? So here now we have a two-player game, but there's a big problem. Our ball isn't doing anything. This game isn't really that much fun if the ball doesn't travel back and forth and bounce off of the paddles. So in the next video, we'll get into how to create movement back and forth on the ball, and how to have it bounce off of these paddles properly, and how to have it ricochet off of the paddles in a way to make the game interesting. But again, like I said, that's going to be the next video. Please stay tuned. I am very excited about this series. It's going to be really fun when we get into the more difficult stuff, but we have to lay the groundwork now. But at this point, sit back and relax, because you have actually applied some programming, some code to your Unity game, and you've made something work. So congratulations, and I hope to see you in the next video. Thanks very much for paying attention.